We are very thrilled that SEQ Water is serious about scenario planning and imagining futures. Full disclosure, I'm a member of the independent review panel for the SEQ Water Water Security Program, which is looking out 30 years. And it's really wonderful that you've done this work to help shape our day. Please share with us what this scenario looks like.
Great. Thank you, ladies and gentlemen. I might just sort of start this when they approached us to generate this hypothetical 2036 flood. We had a bit of an advantage here because after the 2011 flood, we undertook a fairly significant optimisation study of the Ivanhoe Dam, Somerset Dam and North Pine Dam in support of a study that was led by the Queensland State Government through the Department of Energy and Water Supply. And as part of that, we had a good look at all the historical flood data that we could get, understand sort of what happens with rainfall patterns across the catchment, and can we, in a statistically valid way, generate rainfall patterns that we haven't seen and put those on our catchments and test that? And what sort of flood would that produce? Where would the rain go? So with that, we actually produced about 5,000 floods that went into that optimisation study and tested all of those floods with different operating rules. So we pulled one of those floods out for today, just randomly out of the bag. So actually, let's see how this flood event unfolds. So we'll have a look at this photo here. So here's a bit of a nice landscape view. There's a bit of rain happening there. It's not raining everywhere. That rainstorm might be, say, 20 kilometres across. How far deep into the photo is it? Are there other rain clouds to the north, the south, the east? Are they moving in a particular direction? Are they decaying? Are they intensifying? All of these questions conventional design hydrology doesn't really deal a lot with, but it's the reality of what we see. So let's see how this flood goes. Before we do that, you can't really understand a flood without understanding the catchments. So we'll go on a bit of a tour of the catchments. Now, hopefully this works. No. Is this remote active on the... Oh, okay. We'll get this right, yeah. Okay, we're going to go back. Okay, we'll go to the next slide, thanks. So here's the weather god's view of Australia, a long way up into the atmosphere, and we live in Brisbane on the east coast. So we've got a 13,500 square kilometre catchment. Looks pretty small there, but it's a pretty decent sized area that collects water. We're on the eastern side of the Great Dividing Range. The Great Dividing Range helps to really make rain out of the moisture that comes off the ocean. Interestingly enough, that Great Dividing Range travelling down Queensland is a lot like the path that ex-tropical cyclone Oswald took in 2013. It almost hit the Great Dividing Range and just went on a big surfing trip down towards Brisbane and past us. So we'll zoom in a bit on that, just to know that we're in an area that we can get tropical activity, but we can also, are at the top end, almost up to Fraser Island, we get east coast lows, and they happen in autumn and winter. So we're not just in summer floods, we also get autumn and winter floods. Next slide, please. So we'll zoom in on this catchment. There's a map of a catchment. We have two major dams in that catchment, Somerset Dam and Ivanhoe Dam. And next slide, please. Those dams are in the top end of a catchment. About 7,000 square kilometres drains into those dams. That's only about half the catchment of the water that is flowing through Brisbane. Next slide, please. Down below those dams, we have another 6,500 square kilometres of catchment. About 3,000 kilometres squared in the Lockyer Creek catchment. And we also got the Bremer River, Worrell Creek, Purga Creek, all joined to be the Bremer River. That's about another 1,800 square kilometres. And then even further down, all around Brisbane, what we call the lower Brisbane area, so there's another 1,800 square kilometres. Can we go to the next slide, please? So here's the Lockyer Creek catchment, coming off the Great Dividing Range, extensive mountainous areas. This is almost the ideal funnel for collecting water. A lot of tributaries joined together, steep lands, but it's got very rich alluvial fertile flats on its plains and quite extensive floodplains. And this joins the Brisbane River just downstream of Ivanhoe Dam. So let's move to one of the next slide, and here's the Bremer River catchment. So Bremer River has actually got three main streams that drain it. So the Bremer River itself, Worrell Creek and Purga Creek. All of these join together into the lower Bremer River just west of Ipswich. Where those three join together is where Amberley Air Force Base is. That river then flows several kilometres through Ipswich City before joining the Brisbane River. If we go to the next slide, please. And it all comes together in the mid-Brisbane River and the lower Brisbane River. So in the mid-Brisbane River up near Wivenhoe Dam, we've got Lockyer Creek joining in just a few kilometres downstream. Then it travels about 70, 80 kilometres downstream to where the Bremer River joins. And about 18 kilometres of that is actually tidal up to Mount Crosby. Then we've got the Bremer River flowing several kilometres through Ipswich, and about 19 kilometres of that is also tidal. At that key point where the Bremer River joins the Brisbane River, that's a key location that we use called Moggle, and then the river's got about another 80 kilometres to travel through Brisbane, and that's all tidal as well. That area alone, excluding what's coming in from Bremer River upstream, Lockyer Creek upstream, Wivenhoe Dam, just that 1,800 square kilometres has enough local creeks in it that if we get a big rainfall event on that area, we can get above moderate flood levels, potentially above major flood levels just from that alone, let alone what's coming in from upstream. So we'll move along. Next slide, please. Where has the rain occurred in these previous floods? Next slide. So here's a sample of 10 floods that have occurred, say, over the last 125 years up to 2011. Some of them are small, some of them are large. The rain depth on those catchments is not all the same, but we've coloured them in a way to show where the heavy rain has occurred in each of those events. The one that is second from the top left, that's the 1893 flood that Blair mentioned before. So you can see that had the same catchment average rainfall, generally, in a couple of days as what the 1974 flood had. But it was all concentrated at the top end of the Stanley River. Next slide, please. And the dams are in this. So what are the dams? What are dams doing and how are they operated? Next slide, please. So our dams are dual function dams. They provide water supply and also for flood mitigation. So it's very important that we have a certain amount of water reserved in those for drinking water supply. And also that we've got airspace above that, and we need to manage that to protect the safety of the dams. That's absolute top priority. If those dams were to fail, that would be a catastrophe. And we can also use those dams to mitigate downstream flooding. Next slide, please. So the way that we operate, we have a set of rules in a flood manual that gives us objectives, strategies and procedures. Generally, there's a flood mitigation strategy for floods, and that aims to achieve a target flow downstream. And that means that what we're releasing depends on what's happening in the downstream catchments and also what's happening in the dam levels. If the dam levels get too high, we run out of space to store water. So it's a very fine balancing act to actually make sure that you release enough at the right time. If it becomes a very large flood, we might have to go to the dam safety strategy. And in these sorts of events, the releases must increase as the flood gets larger, and that means that extreme floods require large releases. And then after the event has peaked, we need to drain down that dam to be ready for the next flood. Next slide. So let's go through this 2036 flood. I've made it a bit easy, New Year's Day. Where does it rain? What do the tributaries do? How high does it get? How long does it last? Next slide, please. So if we click now, the way I'm going to show this is on the left, on the left, there'll be an image that shows where it's currently raining. This is like our radar view. In the middle, there'll be a map which shows how much depth of rain we've had since the event started. And on the right-hand side, there'll be 4 plots that come up, which shows river flows, how they change over time. We call these hydrographs. Shows how the river flows rise, peak, and then decline again. I'm going to show those at 4 locations: Wivenhoe Dam, Lockyer Creek, Bremer River, and Moggle. So if we can click, please. That's what it looks like. Click again and just let that go. So time's ticking away here at hourly increments. You can see catchments are starting to wet up a little bit. Rain's moving around different directions, generally coming in off the coast from the south. Yeah, still some areas in the catchment haven't seen any rain as yet. Some areas are starting to wet up. Okay, click again please. So here we are 2.5 days after it started raining. There's been light general rainfall across the catchments. The catchments have actually absorbed most of that water, but we are seeing some very early signs of flow in the Lockyer Creek and the Bremer River. The weather forecasts are indicating continuing heavy rain, and the rainfall intensity does appear to be intensifying. Next slide. What's our operational response at this time? Well, at SEQ Water, we decide this is the appropriate point to declare a flood event. Our catchments are wetting up. We are expecting more rain. So what does that mean? That doesn't mean that we actually start releasing straight away. It means that we're declaring a flood event and we're forecasting, and we'll work out the timing of those releases based on the operating rules that we have to work with. We issue a situation report to the disaster agencies, the councils, and our associated stakeholders. The SEQ Water communication teams provides updates using conventional and social media outlets. Most of the disaster agencies are now what we call it stand-up status. The Bureau provides us with an updated briefing, and there's also a flood watch is issued. Next slide, please. Click. And then, yep. So time is ticking away again. We can see that the rain is starting to intensify, and we can see what's happening. We're starting to get inflow at Wivenhoe Dam, but we're not releasing at this point. The reason is because we're getting rising flows downstream in Lockyer Creek and the Bremer River. The Brisbane River at Moggill has increased, now past minor, going towards moderate flood. Click again, please. So at this point in time, we've had quite heavy rain in the last 36 hours. There's significant flood flows occurring in the downstream tributaries. Lockyer Creek is continuing to rise. It's now above major flood. The Bremer River rose. It dropped slightly and is rising again. It's now above major flood level. It's above levels of the 2013 flood, but we're still below levels of the 1974 flood. Where all this joins together in the lower Brisbane River at Moggill, we're approaching a moderate flood classification. The levels are now above the 2013 flood. The heavy rain is continuing, and there's more rain forecast. Next slide, please. So our operational response is the Bureau has issued more flood warnings. Wivenhoe Dam is not yet releasing flood water. We're in the flood mitigation strategy. The inflows are being stored. We're waiting to allow the downstream peaks to pass. We've got about 400,000 megalitres in storage. The peak inflow is predicted to be about 5,000 cubic metres per second. The predicted peak in Wivenhoe Dam is still below the trigger that we need to go to the dam safety strategy. The disaster agencies are in the early response phases to a major flood. The Bureau issues flood forecasts. There's further significant river rises on the way. We expect to get to the 2011 levels in Brisbane and the Bremer River, and we expect to exceed all previous recorded floods in Lockyer Creek. Next slide. What are our impacts at this time? We've got several hundred buildings inundated in the urban areas. We've got extensive property inundation in Lockyer Creek and the Scenic Rim local government areas. Our major regional transport routes to the west and the north are cut. All the roads over the Brisbane River from Colleges Crossing upstream to Wivenhoe Dam are now inundated. And the Brisbane suburbs from Pullenvale to Corona Downs are now isolated because the river levels are backing up over the roads. Next slide, please. So the event continues. Click again, please. So by now, all of the catchment has seen rainfall. It's certainly more intense in the southern parts, but it is actually occurring in many different parts and at different times with different directions of the rainfall moving. We've seen the Lockyer Creek go to a major peak. It's now started, the flows are starting to decline, but there's another burst come and it's starting to rise again. The Bremer River has peaked well above the 1974 flood level at Ipswich. And the Brisbane River at Moggill is now just gone over the 1974 level, about a metre or so higher, say, just for hypothetical sake. So at this point in time, let's just go back up to Wivenhoe Dam. It's had quite a bit of inflow as well too, but it's actually, in this particular event, has had enough storage that to actually, the best strategy here was actually to allow these downstream peaks, floods to do their bit, and we'll deal with the Wivenhoe floodwaters once this event is starting to recede. Next slide, please. So we've now had very heavy rain in the last 48 hours. We've had record floods in Lockyer Creek and the Bremer River. Lockyer Creek and the Bremer River peaks alone, the flows were about double what the 1974 flood was. They peaked early on the 5th January, about 27 hours ago, and Lockyer Creek flow and level has receded. And the current level at this time is about the 2011 peak flood level. The Bremer River flow has receded quite significantly, but the Bremer River level hasn't gone down. And that's because the high levels in the Brisbane River are sustaining high levels backing up the Bremer River at Ipswich. The lower Brisbane River has peaked above the 1974 flood level. The level is starting to recede at Moggill, and the level is about now at the peak level in Brisbane City. Next slide, please. So the operational response, again, the Bureau consistently is putting out flood warnings in the last 48 hours. Around about 24 hours ago, there was enough intelligence with the weather data and the recorded rainfall to predict that the Brisbane level would go above the 1974 flood level, and they issued flood warnings to advise of that. Again, Wivenhoe Dam is not yet releasing water, but it's filling up more. There's about 900,000 megalitres in storage. The peak inflow was about 6,000 cubic metres per second, roughly about 36 hours ago. The predicted peak level in Wivenhoe Dam means that we're okay for the dam safety strategy and we can store that water, but we expect that we're going to need a week of releases to drain that dam back down. The disaster agencies now respond to a major flood, major evacuations, over 20,000 people, services are impacted. Contingencies are implemented where possible. How do you move around at this point in the flood? Next slide, please. What are the impacts at this time? So we've got many thousands of residential, commercial, industrial buildings in urban areas are inundated. The Amberley Air Force Base is inundated. Major regional transport routes in every direction are cut. In the metro area, Ipswich Motorway, the railway, Centenary Highway is closed. We've got inundation in Ipswich City, that's slowly starting to recede. We've got inundation in Brisbane City that's now at the peak. We've got variable power disruptions. How much? Depends how resilient our power systems are. Next slide, please. So we'll continue on a little bit with this just to see whether this rain will go away. It's still lingering, but it's not enough to produce major new rises. Wivenhoe Dam is now starting to release off the back of the flood. Lockyer Creek has still got a minor flow still happening, and Bremer River has still got a bit of flow coming off it as well. Here at the Brisbane River, we're a couple of days past the peak, still at minor to moderate flood level. Next slide, please. So at this particular time, remember back 8 days ago, it was New Year's Day, we sort of woke up in the morning and saw those clouds in the sky. Well, the rain has now substantially finished. The catchment flows have receded. The Brisbane River flows are being sustained now, though, above the minor flood level due to the Wivenhoe Dam releases. So Wivenhoe Dam started releasing about 36 hours ago. So it's now 3 days past the Lockyer peak, 2 days past the Bremer level peak at Ipswich, and the peak generally at Moggill, and it's about 1 day past the Brisbane River peak at Brisbane City. Next slide, please. So the Bureau is continuing to issue flood warnings to advise how long these river levels are going to last and how fast they're going to recede. Wivenhoe Dam is now releasing flood water. It had waited to the downstream levels to drop below moderate flood level. We expect a week of these releases to drain the dam back down to full supply level. The disaster agencies have now ramped up the response work, but not all areas are accessible for cleanup. We've got a gradual restoration of the impacted services. There's a significant focus on cleanup, safety, health, and social wellbeing. Aircraft support to areas that remain isolated. So what are the impacts? Well, at this particular time, about 85% of the area that was inundated is now clear of floodwater. There's a lot of mud around. But the Brisbane western suburbs, Pullenvale to Corona Downs, they remain isolated, and most of the major regional transport routes are open. All of the road crossings across the Brisbane River upstream of the Centenary Highway remain inundated, and probably will for several days. The Amberley Air Force Base is operating, and maybe 80 to 90% of the power is restored at this point. Next slide. So there's no further rainfall, no further rises in the catchment flows. Wivenhoe Dam still has floodwater in storage and needs to be drained back to full supply level. So we need drain down releases to continue for 6 days. Next slide. So what I'm going to do here is just say what's happening at Wivenhoe Dam, because this event hasn't finished. We've still got floodwater up there in the catchment that hasn't gone out to sea yet, and show you the flows at Moggle. So the blue is the flows that are actually occurring, and the red is what would be occurring if we weren't releasing from Wivenhoe Dam. Click, please. So we're releasing at about 4,000 cubic metres per second at this point in time, trying to make sure we can get rid of that water in Wivenhoe Dam within a nominated time frame. We've dropped releases slightly. This allows the Fernvale Bridge to open up and drop releases again. And at this particular point in time, all of that rain that fell on the catchment that produced runoff and made floodwater has now passed through the Brisbane River. Next slide, please. So as a summary, this 2036 flood is a major flood in the Brisbane River and in the tributaries of Lockyer Creek and Bremer River. There's extensive inundation, urban areas affecting the property. The flood duration, the peak level was up for about 12 to 30 hours in different locations. It was a major flood in some areas for over 3 days and above minor flood for about 9 days. Next slide. How does this compare to the past? Well, in Brisbane City and the suburbs, the peak levels were above the 1974 flood level, but they were lower than the 1893 flood level. So we have actually seen floods bigger than this in Brisbane before. In Ipswich City, the peak levels were above the 1974 and 2011 floods, but again, below the 1893 flood. In the mid-Brisbane River, between Wivenhoe Dam, or say Lowood and Mount Crosby, the peak levels were actually lower than the 2011 flood. But in Lockyer Creek, the levels exceeded any previous record known in floods in that area. Next, please. Here's an example of what you might be able to dig out of the archives. That was the 1974 flood, so it gives you a feel for, we've got sort of Ipswich on the bottom left and Brisbane City up the top right, sort of inundation extents that you might see. Next slide, please. There's a close-up of Brisbane City, inundation extents that you might see. And next slide, please. And then sort of about a day or two after the event, the drones sent this picture back to us so we get a feel for what's actually happening across the suburbs. Next, please. Just to wrap up, I'd like to say, I don't know if you see too many telephone boxes like that around anymore. But certainly acknowledge some help on this. David Picaria, one of the engineers at SEQ Water, produced the flood and the animation of that flood. And that was also only possible with the work that was done by Alan Seed at the Bureau and Philip Jordan at Hark Consultants on the rainfall patterns for our previous studies, and also the state of Queensland for a lot of the historical floods, maps and data. Thank you.
Well, what an extraordinary job. Thank you so much, Michael. That's just fantastic. You know, by 2036, my bet is the Internet of Things has moved from the device economy to be an Internet of living things. We have sensors in rivers, on roads. The Bureau may not need to warn us anymore because we're warning each other through big data initiatives. Everyone knows here what's happening in real time until this cuts off. And with distributed energy, we're not quite so sure where the microgrids are and how people are connecting to each other, but let's imagine that we are different in future. So we do have a little bit of time for questions. I know there are some serious flood boffins in the audience that might like to inquire, not just about this, but those other 5,000 stochastic models that are out there. I might, please, and can you please introduce yourself first?
Myself, and that photo's a cracker. The one thing you forgot to mention, Michael, was that we probably put about 3 million tonnes of sediment in Moreton Bay in association with this event. We probably lost about 10 or 15 centimetres off the Lockyer, Laidley agricultural areas, and there's a whole bunch of stuff that's...
But just somebody's loss is somebody's gain too. So
yeah, well, the Moreton Bay's gain, and that photo's a good one. So I think it's really important to, and I was going to raise a question earlier, that I think we've got to be careful today and focus not just on living on a floodplain, but we're living in a catchment upstream of a receiving water. And I think that actually opens up a whole bunch of other processes that we need to be thinking about in terms of potential solutions.
you rock for reminding us. We do have an interlude about this in the afternoon, but all of our interludes should be integrated. And what happens in the upper catchment has a big influence, doesn't it, on how much of that sedimentation ends up in Moreton Bay. We have in the audience Richard Thornton. Where are you, Richard? Oh, just to confuse me. So Richard is the CEO of the Cooperative Research Center for Bushfires and All Natural Hazards. And Richard, I guess just a quick reflection, you know, by 2036, clearly things have changed in terms of the community, in terms of our emergency management framework, in terms of policy settings. Give us a sense of how that might actually look.
We'd certainly hope that things have changed in 20 years. Just a couple of reflections on 20 years though. 20 years ago, as we said earlier on, we were using bricks as telephones. There was no smart technology, there was no information flow in a lot of these cases. It's also worth reflecting that 20 years' time, the people in charge of this event today have probably only just started with their agencies. So as you move between now and 20 years' time, the values and behaviours of those people will be melded by what the senior managers of today are doing with their junior employees, because they will be the ones that are managing this into the future. I think it's also worth remembering that according to Queensland projections, that there'll be another 1 million people living in the Greater Brisbane area. High likelihood that they will be much more vulnerable than today. There's a good possibility that they're made up of people like my kids who think that resilience extends to the point at which the internet goes off. So resilience may not be as high as we hope, but I think it's important that we recognise that. There was a commentary up there that said that it took so long to put the power back on, but there's a good likelihood in 20 years' time a lot of people will be off-grid. So we may not need to worry about getting the power back on because it might be a local thing. And to keep it relatively short, I think we also need to look at how are these current policies that we're working on, whether it's the international policies of disaster risk reduction or indeed local policies, are being accepted at the local level. Because what we do at the local level results in a shared responsibility, and that shared responsibility with the communities are what give us as government agencies and semi-government agencies the licence to operate to do the things that they need to do. And at the end of the day, mitigation is the key in all of this, and how do we build better today to actually resist this type of event.
Thank you so much, Richard. That pyramid of self-reliance may actually be dwindling down to the ground where businesses and households are the key actors. How exciting. I think we have a question here and I've lost you. Please introduce yourself.
Alan Hoban, Blytanner, and also of the Flood of Ideas project. Michael, question for you. After 2011, there were some close calls on the water supply. Mm-hmm. From SEQ Water's perspective, can you talk me through the scenario of what's happening to Brisbane's water supply during this event?
Okay, there could be a couple of different ways this scenario could pan out, but certainly big flows coming off of Lockyer Creek and trying to operate Wivenhoe to minimise the amount of flooding downstream, which is to allow those downstream peaks to pass on this particular flood event and then recede afterwards, means that the flow going past Mount Crosby is predominantly coming out of Lockyer Creek. In the past, we've seen that produces a lot of sediment. In the 2013 event, that produced problems at Mount Crosby in terms of how we operate. But things have changed a bit since then too. So there's different ways in terms of preparing for these sorts of events before that. Make sure all our reservoirs in the urban areas are topped up and full and ready to go. We also have a bit of resilience in the grid as well too. So for instance, in 2013, they actually kicked up the desalination plant. And so while Mount Crosby wasn't able to produce water in certain periods, the desalination plant was able to come on board and actually produce water for the urban areas. That doesn't mean there won't be problems. These are all the sorts of issues that can come up in a flood event, and as much as every flood event is different from what happens with the rain and the river flows, the sorts of issues that come out of the woodwork that you try and deal with during and immediately after the flood event also change from event to event. So it's eye on the ball and think broadly in terms of how you can respond to it.
Thank you very much. Any other questions? I'm mindful, if anyone has an appetite to have a go at this. I am aware that Queensland is currently developing a resilience strategy, a digital strategy, and a climate adaptation strategy. And it occurs to me that there are some overlays between those three, probably many more. How do we as a community of practice come together to influence those so that they reinforce each other? Clearly, someone out there must have a key answer, but I guess we'll just let that one rest. Can we thank Michael and SEQ Water for producing this fantastic hypothetical? So we now have a moment to reflect with Abel Imaraj. Where are you, Abel? You were just, there you are, fantastic, who of course, through Queensland Urban Utilities is sponsoring this event and very active in this community of practice.
Thanks, Mara. Thanks, Michael. Appreciate the time that you've all taken. I want to acknowledge, first of all of you for being here. It's fantastic because I've worked with so many of you in past workplaces, and it's good to see so many of you contributing to this. I'm humbled that you've taken your time to be here and to add value to this. The whole purpose of this hypothetical is really to bring together people, to bring minds together, and hopefully through that, bringing our means together. I think a lot of the things that Mara talked about, we are in a unique perspective today, looking somewhere in the future at something that's just happened. And that gives us a little bit of an idea as to how we can work together for this. The one thing that I am quite keen to talk about is later this year, we'll have pretty much the eyes of the water world across the world looking at Brisbane, because we'll be hosting quite a major event. If people were to look at Brisbane and say, you've had all these things and you're so well informed, what have you done in preparing yourself for this? Also to Michael, to start the discussion off with the 1st of January, I want to wish you all a happy new year. One of the things that about this new year for me was the New Year resolution. A month into this year, and I'm thinking, what happened to my resolution? And one of the things that I want to do was get fitter this year. And the purpose of that was, hopefully, that'll make me more resilient to a lot of the things that I'm seeing around me. And we're beginning to see things we never anticipated, viruses and pandemics and things like that. Maybe being fitter makes me more resilient to the future. But resilience takes resolve. And every day that I have to convince myself to get up in the morning and go for that bike ride or go for that walk. So I think if we're talking about resilience, we need to think about the resolve. I moved into West End the week of the floods, and that was very traumatic, particularly because I was working with a hydraulic engineering firm at the time. So my neighbours wanted to know what I did for a living. I tell them. But that was it. It opened my eyes to what does resilience actually mean for the community. I was frantically looking around for what was this 1974 level, what was the level that I actually got to in this particular part of the world. So I think in addition to resolve, we also need information. And if we, in the first world, are able to bring these things together, bringing our minds together, bringing the information together, and having the resolve to build that resilience, we really can do it. Many years ago when I was a kid growing up in Africa, my life was made miserable because India went through a series of floods. And all my friends, kids being what they are, they said, "You're Indian. What's the matter with you guys? You keep going back to the same area, get flooded every year." Now, I bore the brunt of a whole nation as a kid, thinking, how do I explain to these people? Living in West End, I feel the same way now. So I do challenge you, what can we do together? How can we build that resilience? How can we work together? Could we ever have an agreement on Brisbane River? If it is so central to our society, central to our livability, and we've seen all the different things it does for us, could we do something for the river in reaching agreement on whatever the way it is that we all jointly resolve to do? Thanks very much, Mara.
Okay, fantastic. I do believe we are being fed. How good is that? And when we come back, we're going to go through a set of interludes that bring in the social context, the infrastructure context, the ecosystem context. Be here fed and live and ready to go. See you soon.